We're going to be talking about the magnitude and direction of a vector. So in this case, we're given two examples, and they say find the magnitude and direction angle to the nearest tenth rather for each vector, and then give the measure of the direction angle as an angle between 0 and 360 degrees. So what we're going to do, I'm going to write out number 3, and if I can just get the right pen to work. Here we go. Number 3. All right, we've got the vector that looks like this, 7, 7. So let's think about the graph of this for a second. Okay, so the vector 7, 7, you'd go out about 7 to the right and about 7 up. And so it looks kind of like this, okay? Something like that. That's what the vector looks like, okay? So if you want to find the magnitude, or in this case, how long a vector is, well, think about it. What are the vertical and horizontal components? So here's 7 this way, 7 this way. How would we find this length right here? Well, if you're thinking about the fact that this kind of looks like a right triangle, then you actually have the right idea. Okay, because to find the magnitude of a vector, it's just really a play on the Pythagorean Theorem. Okay, so let's think about this vector and let's give it a name. Let's call it the vector u. And if I wanted the magnitude of the vector u, I would say, well, it's the square root of 7 square plus 7 square, right? So this is 49 plus 49, which is square root of 98, right? Which is the square root of 49 times the square root of 2, which is 7 square root of 2. So this right here is the magnitude, okay? So this right here, if you think about it, this triangle is a 45, 45, 90 triangle, and there's some special property here that this is, if this is x and this is x, then this is x square root of 2, okay? But that's probably something that you learned in a geometry class somewhere, okay? But otherwise, it's very easy to compute. So now let's think about what quadrant this 7, 7 is in. Well, it's in quadrant 1, so Q1. So we know that the angle formed by this vector is somewhere between 0 and 90, okay? So we know it's somewhere between 0 and 90. So I'm going to write that in, 0 to 90 degrees, okay? All right, now we know the property from the formula up above that the tangent of theta is equal to b divided by a. So let's see here, tangent of theta, let me erase this, is b divided by a. So let's see here. If a and b are these numbers right here, then the tangent of the angle theta is going to be 7 divided by 7. And so in this case, we have the tangent of theta. Now let me move this up just a sec. Okay, right about there. The tangent of theta is equal to 1. So we're looking at the tangent inverse of 1. Okay, and if we figure that out, you can use a unit circle. I suppose you could use a calculator, but you're going to get something like this, 45 degrees. So this is the angle formed by the vector, okay? It's a 45-degree angle, okay? All right, so that's one example down. Now let's take a look at another example. We've got this other example here, and actually I'm going to clear my workspace, so if you'll give me 1 second, let me clear it for you. And just like that, it's gone. So now what we're going to do is we're going to look at number 4 here. All right. And it is the square root of 10 and -1. Now let's consider this one. X is positive and y is negative. The horizontal component is positive, the vertical component is negative. So it's going to be somewhere down here. Now I don't know exactly where the square root of 10 is, but I'm going to use my best estimate. And I know that it's somewhere down here because this is where the square root of 10 is positive in the horizontal but negative in the vertical. So we know that this is somewhere in the ballpark of 270 and 360 degrees because we are in quadrant 4. So Q4. So we know our angle is going to be somewhere in there. But first, let's talk about the magnitude. So we're going to call this the vector u. And if I wanted the magnitude of the vector u, I'm going to say the square root of 10 square plus the square root of -1 square. So I get something that looks like that. And what does that look like? Well, this looks like the square root of 10 plus 1, which is the square root of 11. So this right here is our magnitude. All right, now let's consider the direction angle of the vector. So again, we said that it's somewhere between 270 and 360. So what we're going to do is we're going to say, well, the tangent of theta, because that's the formula that we're given up here at the top, the tangent of theta is equal to b divided by a. In this case, again, this is a and this is b, -1 over the square root of 10. Okay, so we've got something that looks like that. And what you're going to do on your calculator is you're going to take the tangent inverse of -1 over the square root of 10, and you're going to get something that looks like, negative 17.5 degrees. So you'll use the calculator for that. But remember, you've got to find a coterminal angle because we know the angle has to be between 270 and 360. So you're going to add one rotation, which is 360 degrees. And let's see what we get here. You do this on the calculator, or if you're good like me, you do it in your head. 342.5 degrees. And guess what? That is somewhere in here, right? That's somewhere in between. So our direction angle is this right here, and that is the angle theta that we are looking for. Okay, so this was just, some information on how to find the magnitude of a vector, again, how long it is, and the angle that a vector forms. Okay, so if this video was helpful, as always, remember to like and subscribe.